So hi guys, so in today's video we would be looking at the SoftPlus function. In the previous two videos we have already looked at the SoftSign function and the SoftMax function, and this is the second last video of activation functions which is really on SoftPlus function. After this video, maybe the last video is going to be on the Selu function, and maybe if possible I would try to upload a video also on Swiss function. So we are coming to the end of this activation function series, and I have covered most of the activation functions which are widely used in ML and DL. So let's start with today's activation function, which is the SoftPlus function. So SoftPlus function is very similar to the ReLU function, but it is relatively smooth. It is a lateral expression like ReLU. It has a wide acceptance range just like ReLU, and the range is between 0 to infinity. So if you look at the formula, the fx is equals to the log of 1 plus e raised to the power x, the exponential of x. And what is the going to be the derivative? So if you don't know how to find the derivative of log x is always equals to always equals to 1 by x. So this whole can be considered as x, 1 plus e raised to the power x. Hence the derivative is equals to 1 upon 1 raised to the power e my raised to the power minus x. So the range is from 0 to infinity. So the SoftPlus function can be approximated by max function, that is max of 0 plus x and 0 to 1. And now if we look at the plotting part, I would just simply change this to TPU, yeah. And let's now run this. I would just first connect it to the notebook to the TPU backend, and after that we would be importing the three important libraries just like always, the math.numpy and math. And I would define my SoftPlus function, that is math.log. If you want to verify, it's here, math.log 1 plus exponential of x, and same we have done. Now we would define the figure size. The input series is, it is going to be minus 20, minus 40, minus 20, 0, 20, 40. And this is going to be the output series, that is every element of element inside input series is going to be put in this output series using the defined SoftPlus function. I would just run this and plot.show, and as you can see these are the values. For 0 we are getting 0, and for you can see minus 20 we are also getting 0, minus 40 we are also getting 0. But when it comes to 20, we are getting approximately around 15, or between 15 and 20. And now let's see the value, the implementation in Keras. So just like always, I just forgot to change this to SoftPlus, and I would just change this. So I have changed it, I have confirmed it, and now we would be looking at the implementation in Keras using SoftPlus. So the SoftPlus activation function, that is SoftPlus x is equals to log of exponential x plus 1. First we will import TensorFlow as TF, and a is going to be tf dot constant minus 20, minus 1, 0, 1 and 20. And we would run this, and now b is going to be the tf.keras.softplus, just like we did tf.keras.activation.relu dot leaky relu dot sigmoid dot tanh similarly, and then we would get the values. And these are the values, as you can see, from the Keras implementation of SoftPlus activation function. Now if you look at the arguments, what it takes, so it takes an input tensor, that is x, and it returns the SoftPlus activation, that is log of exponential of x plus 1. So this was the, I guess, shortest video which was on an activation function. I would just sum up, it is similar to ReLU function. The formula is as following: log of 1 plus exponential of x. This is the graph, and we looked at some of the values here, and this was a following graph. We like every activation function, we are going to implement that in same way in Keras. and the import TensorFlow, define it, tf.keras.activations.softplus, and we get the value. So this was it for the video. I hope you have got an idea. As always, I would just give you the link to this repository in the description section. Thank you and have a nice day.